Lesson 4, Defect Analysis Tools. Now we're going to discuss two tools for defect analysis and prevention. These are the Pareto analysis and the fishbone diagrams. Let's take a look at the Pareto analysis first. Pareto analysis process. Let's take a look at how we can use the Pareto analysis as a defect analysis tool. Pareto analysis is a statistical method of decision-making using a bar chart. It's based on the 80-20 rule, which states that 80% of the problems stem from 20% of the causes. Click the button for a detailed explanation of Pareto analysis. Let's take a look at the Pareto analysis procedure. Number 1. First, form a table which shows the causes and their frequency as a percentage. Number 2. Arrange the rows in decreasing order of importance of the causes. In other words, the most important cause would be first. Also, add a cumulative percentage column to the table. Number 3. Show the causes of the x-axis and cumulative percentage on the y-axis. Number 4. Join the above points to form a curve. Number 5. On the same graph, plot a bar graph with causes on the x-axis and percent frequency on the y-axis. Finally, number 6. Draw a line at 80% on the y-axis parallel to the x-axis. Then, drop the line at the point of intersection with the curve on the x-axis. This point on the x-axis separates the important causes on the left and the less important causes on the right. Let's take a look at an example. Pareto diagram. Example. Let's go through a Pareto analysis diagram showing some website failures and their causes. This shows the frequency of failures along with its cumulative effect and percentage on the y-axis against various causes plotted on the x-axis. Practical difficulties in Pareto analysis. Now let's look at the practical difficulties in performing the Pareto analysis. First, it may lead to misinterpretation of the data. For example, after a Pareto analysis, it is found that some defects were detected only because the latest business requirement document was not made available before the test planning. As well, there are chances of errors in the measurements. To illustrate this, while doing a Pareto analysis, some parameters like website performance, when multiple users access it simultaneously, may not be measured. There also may be a lack of understanding of the application to analyze the specific problem. For example, some defects may be added due to little or no application functionality knowledge. As well, the user should properly know when and how this tool can be used. And of course, there are chances of incorrect plotting of the cumulative percentage data. How about some solutions for these practical difficulties? Let's see how to overcome these problems by using the Pareto analysis. First, properly define the purpose of the Pareto analysis. Properly train the software engineers to use the Pareto analysis as a tool. This helps in effective use of this tool and minimizes process-oriented errors. Then, correctly identify the proper parameters of measurements. Use only standard check sheets to collect the data for the probable major causes. Careful classification of the end results will help you to understand how the Pareto analysis is useful. This whole exercise should be very carefully done. Hopefully, the exercise clearly explained the use of the Pareto analysis tool. Fishbone diagrams. An introduction. For our next defect prevention tool, we're going to take a look at the fishbone diagram. This technique is also called cause and effect diagram. It's a simple diagrammatic methodology to identify the sources responsible for any effect, or it can be used to identify causes behind any problem. It's a team activity which is dominated by the discussion technique. Any decision will be taken only after detailed team-level discussion. This technique focuses more on the collection of valid data. Decision-making can be made only after relating the data properly. It can also be used in analyzing why a process is not giving the expected results. Let's take a closer look. The steps to analyze. Let's go over these steps of the fishbone diagram. As we know, this technique can be used to understand various reasons behind any problem and to point out the effect as a cumulative result of various interdependent causes. So, depending on the situation, focus on the problem or identify the final effect. Accordingly, you would draw the main header line with the problem or the effect circled. For primary level causes, insert the heading inside the circles for primary causes. Cause can be of various types, like methods, people in the process, tools, coffee, etc. Primary causes can further branch at the secondary level. For example, under people, as a primary cause, you can mention strengths and weaknesses as secondary causes. So, you could say that the interlinked cumulative effect of all the causes is the final effect represented on the extreme right-hand side. Fishbone diagram, cause and effect. Let's describe a typical fishbone diagram. The left-hand side is showing the various causes. Some of them are efficiency, performance, leadership, coffee, etc. The final result of all these causes is success, which is shown by the circle on the right-hand side. Further causes can be classified as primary cause or the secondary cause. Another good example would be materials as a cause for further points. The primary cause would be maybe a quality of materials. The secondary cause could be poor quality. Or the primary cause could be the quantity of the material. The secondary cause could be understocking or less stocking of the material that's needed. The end result of all these causes is a problem, delay in delivery of the final product.